Yep, one sec. Yep, I can see it.
Great. So just a recap. We talked about linear equations the other day. Uh,
Yep.
they have to have 1 as the power, the highest power, that is degree, has to be 1. The standard form of a linear equation is ax plus by plus c when it is in the form of two variables. Then we try to find out, we talked about various forms of expression, monomial, binomial, trinomial, having one term, two terms, three terms respectively, and the expressions types when it is about degree. So if degree 1, it is linear. If degree 2, it is quadratic. And if it is 3, it is cubic. Yeah?
Yep.
And then we try to solve a linear equation using substitution, right?
Yes.
Now we are going to talk about another method, which is elimination. So as the name suggests, we have to eliminate a particular variable here. For example, let's say I have x plus y equals 5 and x minus y equals 3. And I'm supposed to solve it for x and y. So just figure this out, that which operation can eliminate one of the variables. For example, you can see if I add both of these equations, what will happen? This x and x will become 2x. Yeah?
Yes.
And then this y plus y and minus y will be cancelled. And then 5 plus 3 becomes 8. This is how we can eliminate one of the variables. Now it's pretty simple. What will be x?
You would just divide it by 2, 4.
Yes.
Could I just write this down a moment? If I can get a
Of
moment just to
course.
write this down.
Sure, sure.
I wrote
Once
that
you
down.
Great. Once you get this x, you can now use substitution in order to substitute it in any of these equations to get the other variable, which is y. So for instance, if I'm putting here x as 4 in one of the equations, so 4 plus y equals 5, so y becomes,
Just trying to.
so I'm
Well,
saying
because y is equal to
once,
5, and y would be 1 from the
yes,
bottom thingy. Yeah, I'm just trying to write this down.
okay. Now this is not only the one way of doing it. I used addition and I eliminated y first. But this could have been done other way also. For instance, I don't want to remove y. Now I want to remove x. So for that, which operation do I need? I need to subtract x from x, right?
Yes.
So I'll take this operation as subtraction. So on subtracting, when we subtract, sign changes, right? If you take
Yes.
away, so second equation will have opposite sign. If it is plus x, it will become minus. If it is minus y, it becomes plus. If it is plus 3, this becomes minus, yeah?
Yep.
So this way x got down, and then 2y equals 5 minus 3. Now you have to see the new sign. 5 minus 3 is 2, and then hence y becomes
1.
and then again you substituted any of these equations, and then your x becomes 4. Is this fine?
Yeah. Let me just write this down because that
Sure.
way I have a. Because I'm trying to listen first so that I understand and then write it down afterwards.
Great. Now, this time I had variables as the coefficient was 1 here. So it was pretty simple. What if I have something like this? 3x plus 2y equals 9 and 2x plus 6y equals 6. In
Okay.
that case, you have to, again, the criteria is same, that you need to make at least one of the variables with their coefficients equal. So for instance, this is 3x, this is 2x. I need to make them same if you want to eliminate x. So what you can do, you take LCM of these two. So I know this is 6, right?
Yep.
So how can I make 6, both of them? I
Well,
multiply
so 2
this
multiplied
equation.
by 3, 3
Yes,
multiplied by 2.
perfect. So what I'm doing now, I'm transforming this equation by multiplying the whole equation by 2. So this becomes 2 times 3, 6x, 2 times 2, 4y, 9 times 2 is 18. And the second one will become 3 2s are 6, 3 times 6 is 18, and 3 6 are 18. Is this fine?
Yep.
And now the part is same, that I can use subtraction here, and then I'll change the sign, and then I'll cancel this out. I'm left with 18 minus 4. So can you please tell me, help me with this? 4 minus 18y. What will you get?
Sorry.
It's all right. 18 minus 18. This is also down. So y becomes 0 by minus 14. That is what?
0 by, that'd be 0, is it not?
Yes. So once you get one variable, you can just put this back to either
Into
this
the,
equation or this one, whatever you like. So 3x plus 2y equals 9. If you substitute here y as 0, you will get 2 times 0 is 0. X becomes 9 over 3, that is 3. Yeah?
yeah.
Please have a note of it.
Yeah, I'm just gonna read that, yes.
Now, if you've got it, could you please try this one for me?
1 sec. Yep.
Is another way of verifying it whether my answer is right or not, that you take up any of the equations
Hmm.
and you put the value in that on that side where you have x and y. So I'm taking up left hand side and I'll substitute what I've got. X is 2, y is 0.
Yeah. Yeah,
And
that's
then
one of the ways I deduct. I did the way you showed me, and I did that way too.
oh, that's great. So
Because I
if it
prefer this
becomes
method. So I know for sure if my question's right.
okay, great. So this is it about the elimination. Now, if I have to find out how many solutions, so first of all, what is a solution?
A solved equation, something that you've solved for. So if we're solving for x, what x would be once it is solved.
Correct. So graphically, these are the coordinates on the Cartesian plane, right?
Yes.
So if 1, 2, 3, 1, 2, 3, so y is 0 and x is 2. So that means this is on the x-axis, right? This is one of the solutions of this equation, okay?
Yes.
So how can I figure out just by seeing at the equation whether it is going to have unique solution, infinitely many solution, like uncountable, many solution, or if there is no solution?
Could you explain all of these? And
Yeah,
I'll write these down afterwards. Just explain them, and then I can write it down
sure,
afterwards.
sure. So for instance, let's say I have this equation, I had this equation. I got this 2 comma 0 as my solution. So I had only one particular answer which can satisfy both of them. So I'll say that this equation has only one solution, that is unique solution. Okay.
Okay.
And there, standard form of equation is this: ax plus by plus c equals 0, right?
Yes.
Now, if I have two equations of this form, so two equations means the coefficient is different. So I'm writing this as this one, that I have two equation of this form,
Mm-hmm.
maybe 2x plus 3y plus 4 equals 0, and 4x plus 6y plus 8 equals 0. So you can see what is A, B, and C for first one.
A for first one is 2x. B
Uh, so,
for
so A is without x, just the coefficient.
2, sorry,
Yeah.
2,
B
and
is,
then B is 3, and C is 4.
yeah. And what about this one? So this one
Uh,
A1,
A,
C1.
A is 4,
Yeah.
uh, B is 6, and C is 8.
Okay. So now what you're supposed to do, you just take the fraction of these, you divide all of them and see whether they are coming out as equal or not. So for example, if you do A1 by A2, that is 2 by 4.
Yes.
So this becomes 2 ones are 2, 2 ones are 4, so 1 over 2. You do B1
Mm-hmm.
by B2. This is what? 3 over 6. That is again 1 over 2. You do
Mm-hmm.
C1 by C2.
That's again 1 over 2.
1 over 2. So if you see that if your fraction, your ratio of the coefficients turn out to be equal, that means this is the case of infinitely many solution. I'm telling you how. You see this, if I simplify second one, can you see all of these have 2 as common, right?
They have a LCM, which would just cancel them all out.
Yes, so second equation will be transformed to 2x plus 3y plus 4 equals 0, right?
Yes.
Which is nothing but the first equation only.
Yeah.
So if I have one equation, only one equation, and I want to find out its solution, so what it will be? I can try putting down those values in place of x and y, which can give me right hand side as 0, right?
Yes.
So I can put any of the things which can make it either 0, or you can keep this here and 4 as minus 4, right?
Yes.
For example, if I place x as 1 and y as minus 2, tell me what will I get?
If you have x as 1, then it would be 2, and then negative 6. 2, 2 plus negative 6.
That is,
2 plus negative 6, that's negative 4.
which is right hand side. So this is one of the solutions. And similarly, I can find many, right? Which can
Yeah.
satisfy minus and give me minus 4. Correct.
Okay.
So this
And
is
then,
how, huh?
and that's infinite solution, correct?
Correct. So for
Okay.
infinitely many solution, the you just need to, if question has just asked me that how many solutions will this set of equation be having, so you will just find out the ratio and see if these are equal, infinitely many solution will be there. Now
Okay.
for unique, that is only one solution, only exactly one solution, you need
Okay.
to have all of them as unequal ratio.
Hmm.
So for instance, you solve this and you found one solution. Could you please help me in getting A1, B1, C1
For the 15x 1, correct?
for the first main equation, not the
Sorry, which equation?
transformed one, the main
So
equation,
the
not
main
the,
equation. So
yeah,
3 would be your A,
yeah,
your 2 would be B,
minus
and
2. You
6
need to consider the
minus
sign.
sorry, minus 2 would be B, and 6 would be C.
Perfect. What
And
about
then
A?
5 would be your A,
Yeah.
minus 5 would be your B, and 10 would be your C.
So if you do A1 by A2, what it will be?
A1 over A2, it would be 3 over 5, which would be, uh, yeah, 3 over 5. And you can't simplify that any further.
Yeah.
And
You
then
you
it would
was
be
hmm,
2 by 2 over negative 2 over negative 5, which you could just say 2 over 5.
yeah,
And then 6 over 10, which you could simplify if you wanted to. It could be
yeah.
3 over 5, I believe.
So can you see none of them is equal?
No.
So you can see that I have only found there will be no other value other than x2 and y0 which can satisfy this equation. So for unique solution, you will be having this condition that none of the ratios are equal. Okay.
Okay.
Now
Just
comes no. Yeah.
once you
Go ahead.
explain this, I will write everything down because I want to
Yeah.
hear this and then I'll write the rest of it down.
Yeah. Sure. When it is no solution means if I have to understand this graphically. See, if I make graph of one solution, I have x axis, I have y axis. I could have negative part also, that is fine, and origin. So if I have two equations, linear equation have always a straight line. Let's say I have this as my, these are two equations, any of the equations. So can you see there is the point of intersection? This is actually
Uh,
my solution.
that is your solution. So I would, like, if it was in a graph, maybe I would say, 3, 2, maybe something like that.
Yeah, let's say,
Let's go 3x and then maybe 3 or 4x,
yeah,
somewhere there.
yeah. So you will say that if lines are intersecting at one point, that is when they have unique solution. And
Mm-hmm.
this is the condition when your ratios are not equal, okay?
Yes.
But let's say you have this line, and then again you will be having line over this only.
So
If
the same
lines
exact
are,
thing.
yeah, go ahead.
So line over top meaning that they're the same.
Yes, the overlapping lines. For instance, we did this one. You can see that in you are just multiplying the equation with one factor. So you can take out that common and you will get the same equation back. So actually these are, if you plot them, these are nothing but overlapping lines, right?
Yes. Sorry, could you go to yeah. I see.
So I have 2x plus 3y plus 4 equals 0. Then I have 4x plus 6y plus 8, 0. But actually 4x plus 6y plus 8 is first equation only, right?
Yes.
So this is actually overlapping lines. Both of them are equal. So I need to draw the graph for any one of them, correct?
Yeah.
So hence I'll say that if I have the set of overlapping lines, that will be the case of many solutions, infinitely many solutions, because these are overlapping lines. And that is the case when the ratios are equal.
The
Okay.
equal.
But when there's a case of no solution, that means my lines are not going to intersect at all. And that can happen only when they can be parallel, isn't it?
Yes.
So if they are parallel, they are not going to meet each other at all. And hence, this is the case of no solution. Okay.
Okay.
And that can happen for parallel lines. I'll tell you when we'll talk about slope intercept form also. This will come again there.
Yes.
Um,
So and plus b is equal to y, correct?
yes, correct. Perfect. So here you have first pair as equal, but it is not equal to third pair.
Oh, okay.
So this is the case of parallel lines. Is it clear?
Okay. That, yeah, I get that. That's
Okay.
pretty simple. Could you go back to the very first when you go over solution? Uh, yeah, because I'm just gonna
Huh.
maybe I'll screenshot this and write this down later. That way we can.
Okay. That's your call. Take your time if you want to jot down or if you want to
No, it's
take.
okay. I can because I can jot it down. Sorry, what happened? One sec.
Yeah,
This. Oh, sorry.
no problem.
Okay, and all right. And then could you go towards the other towards your right so I can see this?
Yeah.
Yeah, that's perfect. There we go. I've gotten a screenshot, so I'll write it
Oh,
down later in my notebook. That way we can focus on.
great, great. Now, could you
Okay.
please read this question?
The very first one
Yeah.
on comparing the ratios.
Yes.
On comparing the ratios, A A B C A B
Basically,
C
this is how you write. You distinguish that the A subscript 1, that is A1 and A2 are two
A1.
different ratios.
Yeah. Find out whether the lines representing the following pairs of linear equations intersect at a point, are parallel or coincident. So intersect at a point, meaning that would be they have a standard and there's like a unique answer. Parallel
Perfect.
meaning there is no answer, and coincident meaning that they are on top of each other.
Yes, many solutions. So,
Okay,
what is A1 by A2 here?
A1 by A2 is 5/7,
B1 over
uh,
B2,
4/6.
including sign, please.
And sorry, -4/6 or
Yeah.
6.
So, on
And
simplification,
that would be negative, sorry, -2/3.
and C1 over C2.
Uh, 8/-9, which would make this would intersect.
Yes, unique solution, intersected point.
Also, I had
Then,
another question. Sorry, I can't see. Second one is the 9x, correct?
yes.
Okay, so the first 2 points, this one's, I believe this is they are coincident.
Oh, that's perfect. So you have, you can take out common.
All would are multiples, all of
Yeah.
the numbers.
So if you take out common, two threes are, two ones are, two twos are, and then you take this two to right hand side, it will give you zero only, so which is as same as the first one. So it is which case?
It is coincident, I believe.
Yeah. What about the third one?
Third one, let's see. It's two, so that would be, sorry, this would be 1/3
One by three, are you sure?
for, sorry, 3/1. Oh, not 1/3.
Yeah.
3/1. The second one would be 3/1. And then the third one would be 10/9.
Which is clear case for?
This is, sorry, one sec. The first two are in line, so it is what is it called? It is a parallel.
Yeah.
There's no solution. Because
Now,
the first one matches, the second one does, the third does not.
now this can be rephrased into another thing which is called as consistent or inconsistent. So consistent is the case when you have solutions, be it one solution or many solution.
And inconsistent means there's no solution. Okay.
So indirectly what they want to ask for.
Sorry?
Indirectly what they want to ask for in this question.
They're asking for whether if is it like indirectly they would be like does if the A's if it's parallel or if it's parallel, that's what we are. That is like a no solution. That would be inconsistent. Versus if it's any of the others, that means it's consistent. They're looking
Perfect.
for an answer. They're
Yes.
looking for a solution.
Yeah.
If there's no solution, then the answer is that it's incoincident. Sorry.
Correct. So come up with the first one. What do you think? What it is?
Cool. For this one, okay. Two. That would be 3 by 2. 2 by 3 and okay, this one is that's a C. First one is consistent,
Okay.
meaning there is
Which which type of consistency it is having?
it is what's it called? To look back at what they're called. It's not parallel, it's not inconsistent, it's forgot the
Unique
name.
unique solution
Unique
intersecting
unique
points.
solutions.
Yeah.
Intersecting. Correct.
Okay. What about
And
second one?
the second one that is inconsistent.
Inconsistent because it is 2 over 5 for A1 over A2. 2 over
Yeah,
4.
they
That
all
is
points are correct. The second one does not match. Sorry, the third one, not the second. Third one does not match.
okay. This is in fraction.
So it is already okay. So this is in fraction. Oh, in this
So
five.
there are okay, you try.
Okay. Twos. Okay, and then so 3 by 2. 5 by 3. 7. Okay, couldn't you find the LCM for this one?
Yeah, so you can solve it in order to make it in the standard form. This is one way of doing it. So if you take LCM, do you want me to do or you are doing it?
I think I can try it. So
Okay.
3, 2 plus 5, 3. And then for the 7, we would also have to do it.
Okay.
Question, would we do it for all of them? Or would we just do it for the first part of the equation?
First part, the fraction one, because other one is already in a standard
And
form. Just you can bring it
what
to
about
left
the
hand.
7 and the 8? The 7 and the 8, would we also do that too, the answers?
So basically, you are solving left side with the LCM, and then once you get the denominator, you take it to right hand side and multiply. Does this make sense?
Okay. Yep, kind of, yes. That would be 6. 6, so 18. 6. No, no. That's 1 sec. So that
Yeah.
would be 6. So 3, 3. So 9x plus 2. That's 10. Y is equals to 7. 9x minus 10y is equals to 14. This is an inconsistent.
So just to reiterate, you have 3 over 2x, 5 over 3y equals 7. So if you take LCM, this is 2 and 3, that is 6. So you will make this as 6 by multiplying by 3 and this
Mm-hmm.
by multiplying with 2, right?
Yep.
So this becomes 3 3s are 9x. This becomes 5 2s are 10y equals 7. And then you take this 6 to right hand side. This is what you got.
Yes, I think. Yep.
Great. Other way of doing it was if you want to do it directly by fractions, but there are chances of error there. So I have A1 as 3 over 2, B1 as
Yes.
5 over 3, and C1 as, if you want to take it to left hand side, it would be minus 7. But then minus 7 by minus 8 is not making any change in it. So you can keep 7 also, okay?
Okay.
Then your A2 is 4 over 3, B2 is 2, C2 is 8. So now
Okay.
A1 over A2, 3 over 2 over 4 over 3. And you know what is it? It is in division form. And whenever I have
Which
to
you
divide,
reciprocal, and you would have to figure that. That's a lot more work
yeah, it is lot also. And there are chances because you have to flip the second part. You have to
because it's
change the division
reciprocal. So, and you would have, and it's chances of more error.
error. Yeah. So this is one way of doing it. So you get this as 9 over 8, which is ultimately this one only. 9 over, if you take the LCM, you will get 9 over 8 only. Yeah.
Okay.
Oh, this
Got
was
it.
the different part. Yeah. Altogether
Yes.
fifth. Okay.
Yes.
So did you get it? How to solve it?
Yes, I did.
Okay. So these rest of the parts, like fourth and fifth one, are from homework. If you can take the screenshot so that we
Of
can move.
the, sorry, fourth.
Fourth and fifth,
So
the
four
remaining
and
two.
five.
Yeah.
Oh, is it okay if I take a screenshot of what you've written
Yes.
so I just remember?
Oh, yeah.
Yeah.
The one which I
It's okay.
deleted.
That one is fine because I just want to see the bottom part. Oh, it's hard to
Yeah.
screenshot on this 1 minute.
Okay.
It's very okay. Yeah. Yep, I screenshotted it and I should have the work. Yep.
Okay. Now again, this question, if you read it, please. The
Which
following
question?
one.
Oh,
The
this one.
following.
Which of the following which of the following pairs of linear equations are considered are consistent, inconsistent? If consistent, obtain the solution graphically.
So
Okay.
this is pretty clear that you have to find out whether it is the set of equation is having solutions or not. Yeah, if having solutions means
Yes.
consistent, and if not, it is inconsistent. But it is asking me if they have solution, that is, if they are consistent, find the solution, but not by elimination, not by substitution, instead graphically. So how would we do that? I'm telling you, second part, and then you will do first and third. Okay.
Okay.
So first of all, I'm checking. I think this is pretty clear. A1 over A2 is what here?
A1 over A2 would be 1 over 3,
1 over 3 here. B1 over B2.
and then it would be minus 1 over minus 3, so 1 over 3 again, and
And then
then it would be 8 over 16, which is I think
1 over 2,
1 over 2,
which
which
is the
would be
case
inconsistent.
inconsistent. I should not have,
Inconsistent.
yes, I should not have picked it. Okay, let's try this one. 2x plus y minus 6. 4x minus 2y minus 4 equals 0. So now, if I take the common, this will become 2x minus y equal, yeah?
Yes.
Again, tell me what is a1 over a2?
A1 over A2, like the simplified version or the regular?
Yeah, the simplified.
Simplified, that's 2 over 2, or
That
1.
is, yeah.
Second one, it is Nick. That is 0, because
No,
pause
it, it is 1 over
1,
minus 1. That is
so
minus 1.
minus 1. And then it is minus 6 over minus 2, which you could say is uh 3 over
1.
1 or 3.
Yeah. Remember always, if let's say they have given you -6 onto the left hand side, but they are giving you 2 as this thing, 2x minus y equals 2. Always change them into the same form, because if you now try c1 over c2, this will give you -6 over 2, which is wrong. Either you have to have everything on the left side, or if you
Okay.
want to keep the c part on right hand side, just make it uniform for both of the equations, yeah, so as not to get confused with signs. Yeah,
Okay.
do you want me to tell you this again?
Yes. Could you write it down so I can just take a
Yeah,
photo
yeah,
of that after so I
sure,
can.
sure. For example, if question has given me this form, that 6 they have taken to right hand side, and then they are giving me the another form in this way, 2x minus y minus 2 equals 0. Okay, so while
Yeah.
finding out c1 over c2, don't write it this way, 6 over minus 2, because these are not given in the same format. Either you could be having ax plus by plus c equals 0, or
Okay.
ax plus by minus c. But you cannot, so if it is right hand side, you bring this
Because
c
the six
also.
one,
Yeah.
the six is the answer versus theirs is zero is the answer, so you would have to bring the -2.
Yes.
Okay, that makes some sense. Yeah, I get that.
Okay.
Because if you
Now,
did this,
uh,
it would be -2, which means there would be no answer on this side. Because here it's you would have a1, b1, and minus, and then you would have c1, but it wouldn't be c1 necessarily, because that's the
perfect.
answer.
Yeah.
Yeah, I mean
This
that
is
I understand that.
okay. So now you can see that this is the case, clear case of which type of equations?
This one,
A1 by
this
A2.
is uh, hold up 1 second. Sorry, I can't really see the equation.
Hold on.
Yeah, I think
Uh,
you gotta scroll up. Maybe I can't really tell. Kind of
uh,
confused where we are.
okay, no problem. This is A1 over A2. This is B1 over B2, and this is C1 over C2.
This is I would say this is consistent.
Consistent, and which case?
Uh,
Intersecting or
intersect.
coincident?
Ins
Yes,
intersect.
intersect. Okay. Now the question has asked me if it is consistent, you need to solve it graphically, yeah? So I need
Yes.
to take this up. 2x plus y minus 6, 2x plus y minus 6, and then this is 4x minus 2y minus 4, just to cross check. 4x minus 2y minus 4. Yeah. Now I need to solve this. So how would I do that? I'll make a table.
In input values, I'm guessing.
Yes. And draw the graph. And you will see that it is going to be intersecting at one point only.
So,
That is me.
this is simple. You just take it. So if I have, you would put the same values of x and y for both sides, and then you would see your answers, and then you would just plot the point accordingly.
Yeah, but for plotting, at least I need to have two solutions. I mean, 2 points, because then only I could join them and make a line. Yeah. Otherwise,
Yes.
I would not be having any clue with the point where is it going, because a point can have infinitely many line passing through it. Yeah.
Yes.
So you can have y as 6 minus 2x, and from here, if you can simplify, this will become this, then you can bring this y to right hand side, and this will become 2x minus 2, right?
Yes.
And now you
Sorry,
start. Yeah, go ahead.
could you just hold on for a second?
Sure.
Uh, Sorry, 1 sec. Yeah, sorry, there was just a call coming in between. Yeah,
No problem.
continue.
So I'm saying that I have simplified the second one into this way, and then I'm isolating the variable. I have kept y onto the right hand side, and then 2x minus 2 on left. So this way I have one the expression of one variable in the form of other, yeah?
Yes, okay.
So now start substituting. If I place x as 0, what will I get as y?
X is 0, you would get 6 is y.
Yeah. If it is, let's say x1, so y will become
1, y will be, if x is 1, y would become 4.
4. What about x2?
X2, y would become 2.
X2, so y will become 2, yeah. X3,
0.
0. Okay. Here, x0.
If x is 0, y, sorry, I can't see that.
Oh, hold on.
If
We
is
write it properly. 2x minus 2.
x minus 2, then it would be my negative 2.
Yeah. If x is 1,
It would be 0.
if x is 2.
It would be 2.
So can you see this is my unique solution?
Yes.
And then if I start plotting it,
On the graph, you can plot each point.
yeah, and then you
Yeah.
can show that this is having consistent. Would you be able to
Yeah.
do it?
Yeah, I would be able to do that.
Okay. So just to summarize what we have talked about, if I have a set of linear equation, a pair of linear equation actually, and you find out their ratio, if it is not equal. If first one is not equal, then you no need to find out the third one because that will be the direct case of intersecting. That is one solution that is consistent. Yeah.
Yeah.
Then if
I'm
you
just gonna,
have another set and there you have all of them equal, that is when you have coincident lines and infinitely many solution. Again, this is the case for consistent, yeah?
yeah.
And then if you have the pair and first one is equal, another one is not, that is one equal, another, this is the flipping of equality. Then this is parallel lines, no solution. That is inconsistent. Does this make sense?
Yeah.
Okay. What is that which you want to take screenshot of?
I'm just gonna take a screenshot of everything slowly. One sec. This phone is not letting me take screenshots. Oh no, one sec.
You can make a
I'm,
folder on Drive, and
yeah,
then
that's what I do.
okay.
Okay, I took it. And now could you scroll up a bit so I can see the very, yes, that's it. Yep, that's it.
All right.
Yep,
So
I've got it.
this was it for today.